Today, I am Dekadet Bahikian, a second year student from the University of Cebu, MET-C. Today, I'm going to share my knowledge and learnings on what I have learned from our topic that is being discussed and on the course files and site that is being posted in our Moodle from our subject Meteorology and Oceanography 1 or MET-O211 from week 1 to week 4 finals. In week 1, the topic focused on the anticyclone and other pressure systems, and also on the ridge, trough, and cool. In this topic, I have learned on how to identify what is ridge, trough, and cool, and also on how to differentiate the ridge and cool between convergence of pressure systems on a surface, synoptic, and prognostic chart. So first, what is a ridge? So a ridge is an elongated area of relative high pressure system compared to the surrounding environment without being a closed circulation. It is associated with an area of maximum curvature of wind flow. The ridge originates in the center of the anticyclone and sandwiched between two low pressure areas, and the locus of the maximum curvature is called ridge line. Sometimes, in discussion of the atmospheric waves embedded in the westerlies, a ridge line is considered to be a line drawn all the points at which the anticyclonically curved isobars or contour lines are tangent to the latitude circle. It is also characterized as an opposite of the trough. So what is trough? A trough is an elongated region of relatively low atmospheric pressure without a closed isobaric contour that we define as a low pressure area. Since low pressure implies a low height on a pressure surface, troughs refer to the features in an identical sense as those on a topographic map. Troughs may be at the surface or aloft. If a trough forms in the mid-latitudes, a temperature difference at some distance between the two sides of troughs usually exists. The trough might become a weather front at the same point. However, such weather front is usually less convective than a trough in the tropics or subtropics. Next is the cool. A cool is also called as the saddle point or the neutral point in the term of the meteorology. It is the saddle point or the point of intersection of a trough and ridge in the pressure pattern of a weather map. It takes the form of a saddle where the air pressure is slightly higher than that of the low pressure region, but lower than that of the anticyclonic zones in the weather map as one to the right. A cool region where the position of highs and lows produces a convergence or the divergence of the airflow. This includes the two juxtaposed highs and two juxtaposed lows. In addition, the converging lines are band of clouds and rains that is formed from the different direction of wind, and it can lead to the wet persistent or the high rainfall. In week 2, the topic focuses on the decoding and coding. In this topic, I have learned on how to decode and code. In the history of the decode and coding started nearly 150 years ago, long before the invention of the radio. Apart from reporting the weather by radio, which started in the 1906, changes have been gradual in the 1946. All the members of the British Commonwealth decided to cooperative in organizing meteorological work at sea. A year later, the WMO was formed and extended this cooperation to include all countries and introduce a universal code to standardize all weather reporting. So, what is the decoding and coding? So first, the decoding. The decoding is the method in which you change the gathered data from numbers to words. And in coding, it is changing the gathered data from words to numbers. So it is a vice versa. The letters and numbers in each correspondingly encoding and decoding have different functions. In week 3, it focuses on the weather observation on board ship. In this topic, I also learned the ways and methods of the seafarers on how they forecast the weather on board ships on their way on the route or docking in the port. This topic is very helpful to me because I can apply my knowledge on what I have learned if I am on board the ship soon. Weather forecast for seafarers is important because it helps them to be aware and be ready on what weather that might they encounter in the open seas or docking at the port. It is easier for the seafarers to forecast weather with the use of the technology that can determine on what weather might be to encounter. The weather forecast contains a lot of meteorological information, tools, and also the processes on board the ship that is needed, and it is the requirement for the safe navigation or safe practice of navigation. In weather forecasting on board, weather maps are present that serve as our guide in determining the path of what weather might be encountered. A weather map displays various meteorological features across a particular area at a particular point and has various symbols which all have specific meaning. The weather maps that are present on board ships are the analysis maps and prognosis charts. Analysis maps are based on the weather observation from which patterns of highs and low as well as the locations of the weather fronts are drawn, while the prognosis chart are displayed on what weather is expected to be like at a future time. In other words, a forecast map. Much of the accuracy of the charts depends on the skills of a meteorology or the analyst who draws the pattern based on his interpretation of his observation. Also, the weather messages are important on board ship for the communication and also to spread the awareness of their gathered data of the weather warnings on how strong, calm, or good weather might be. In weather forecasting, there are also techniques and methods. The technique used with the surface analysis charts in tracking the weather is based on the idea of the past is an indicator of the future. A minimum of 2 surfaces analysis chart received each day is recommended, and more than with this when the situation is rapidly changing or critical operation, the requiring the most up-to-date information are involved. The methods of weather forecastings are the historical forecasting, persistent forecasting, trend forecasting, synoptic weather forecasting, numerical forecasting, and the computer models. These forecastings are characterized to identify the forecast easily by knowing its functions and in what situation that is needed to be used. First is the historical forecasting. It is the predicting the weather by assuming that it is happened in the past and will happen again this time. It is also one of the methods that is used to predict the tracks of the hurricanes. Next is the persistence forecasting. It is the simplest method and often reliable over periods of minutes or hours. In most locations, persistence forecasting doesn't work well for periods longer than a couple of hours because the temperature of the cloud cover often greatly between morning and afternoon and in between day and night. Next is the trend forecasting. It is a more reliable and versatile method of short-term forecasting that involves the assumption that a current tendency or trend will continue or that observed the cycle will repeat. It is a form of extrapolation of extending a defined rate of change in the future. Next is the synoptic forecasting. It is the comparated to the analog communication, in which variables can change continuously. Next is the numerical forecasting. It is more like digital communication, in which the variables are broken up into small parcels or packets, and the behavior of the whole system is deduced by the brute force of calculation based on the laws of physics. And lastly, the computer models. It is also helpful to the seafarers because it is used to forecast the weather trends for approaching months and season. And the last topic that is being tackled is the determining the names locally and internationally of the typhoons and hurricanes. In this topic, it increases my learning on how typhoon has been named locally and internationally, and also why the names of the typhoon are repeated, and also the duration of the years when the typhoon names are being repeated, and on what the institutions or agencies that is being assigned on different parts of the world where the typhoon is located. So first is the naming of the typhoon appears to have originated with Clement Ragg, an Australian meteorologist who in the 1890s entertained himself by naming storms after women, mythical figures, and politicians that he didn't like. The system was formalized in 1953 when the National Weather Services put together an alphabetical list of names of females to be used for storms in the Atlantic Basin. Short and quickly understood names were easier to transmit over the radio and easier to keep straight if there was more than one storm in a given area. Later, in 1979, male names were added because it is pointed out the sexism of the women's group of using only females' name. The local naming is being used when the typhoon is being passed on a country. For example, in the Philippines, Bagyong Pablo, but in other country it has different names. Where it is being named in our country, like the Philippines, because the Bagyong Pablo passed it in our area of responsibility. Then the names are taken from 4 different lists of the 25 names that is being assigned when the system moves into develops into a tropical depression within the Pag-asa direction. So the 4 list of names are rotated every 4 years. The typhoon name will retire if it causes a massive damage in our community, like the Bagyong Yolanda or Haiyan in international name, that affects a lot of structures and lives of people in the country. So the international naming is being assigned by the Japan Meteorological Agency within the Western Pacific. There are many institutions that being assigned on its corresponding area and is being divided in the South and North Hemisphere. For example, an institution that's being assigned in the North Hemisphere is the United States Central Pacific Hurricane Center, that is being assigned in the area of responsibility in the equator northward 140 degree to 180 degree, and in the southern hemisphere an assigned institution is the Brazilian Navy Hydrographic Center that covers the equator 35 degree to south and to the Brazilian coast of 20 degree west. And this is all my learnings from our topic from week 1 to week 4 finals. Thank you for listening and watching my video.